Alright, should be live now. Let me help others get on. Alright, so I'm going to go over the practice test. Let me pull up the practice test. And I am backwards. Let's flip it. See if this helps. Alright, practice test. Question number 1. T of x equals 5 over x minus x. The question says determine whether each function is a rational function or not a rational function. If the function is not a rational, explain why. So we'll review rational functions are basically fractions, and your integers, your exponents should be integers or whole numbers. So here, this part is not a rational function, but this part is. It's a fraction. Its integer up here is a whole number. It's not a fraction, not 2/3. It's not a negative. So determine, the answer is yes. It is a rational function. If the function is not rational, then you have to explain why. So because it's yes, that's the answer for question number 1. All right, question number 2. Use algebra to determine the vertical asymptotes of each function. So I have h of x is 2x over x squared minus 9x plus 8. All right, so we're supposed to use algebra to determine the vertical asymptote for each of these. To find the vertical asymptote, you're going to set the denominator not equal to 0. So here, I'm going to have to factor first. So before I set this not equal to 0, or you can do it now, you're going to have to factor this. And then to factor this, we're going to use our Xbox method of factoring. Remember, this is your A value, B, and C. The A, B's, and C's come from the numbers in front, or coefficients. So A times C, 1 times 8 is 8. B value is -9. We need to think of two numbers that multiply, or their products, equal 8. And the same two numbers, they add, or their sum is -9. So I'm going to think of those numbers, 8 and 1, and if you make those negative. So -1 times -8 gives you a +8, -8 plus -1 gives you a -9. So if I factor this, now I have x minus 8 and x minus 1. Now I can set both of those not equal to 0. And then you just solve. Remember, don't get intimidated by the not equal sign. Just make it pretend it's like an equal sign. So I'm going to add 8 here. And over here, I'm going to do the inverse or opposite. This equals 1. I'm sorry, that equals 0. And this one equals 1. So our two vertical asymptotes here are at 8 and 1. So we're just going over the practice test. This is question number 2. It says use algebra to determine the vertical asymptotes of each of the functions. All right, let's move on to question number 3. So you guys already have the PDF version of the test. You've had it for a week. And now we're just going over the questions. Number 3. I have this problem, 10x squared y 3x times 21xy over 20y. And this problem says perform the indicated operation, list any restrictions for the variables, and simplify the answers when possible. So the operation that we see here is multiplication. Multiplication is nice. We don't have to have a common denominator. Now to simplify these, you can break the constants into factors. So 10 would be 5 times 2. I don't think I need to break up these, x squared and y. I have 3 times x. 21 is going to turn into 7 times 3, xy. And 20 is going to be 4 times 5. Now that I'm looking ahead, this 2 here is going to be turned into a 4. So I have 2 times 2. Okay, because this is multiplication, you're just looking for those that are the same. 5 divided by 5 is 1. That's why I'm canceling those. So canceling in this case for multiplication is just 1. Y divided by y is 1. 1 on top, 1 on the bottom, and then there are 3's. And I have 1 set of 2's. Okay, how do you know you did that correctly? You should never have, on my finished problem, an x on the top and the bottom. So 7 x squared times y. In the denominator there, I have no x's or y's. Just have a 2. If there's a situation where you do have an x or y, for example, if I have another x there, then you can simplify again. Remember, you don't want any decimals or fractions here. And this is our simplified answer. Now I'm going to leave my box kind of big because I'm going to list the restrictions are on the denominator. So denominator not equal to 0. So go ahead and put your finger on the variable there on the denominator. There's 1. Now, a lot of students were asking this question in class a couple weeks ago. Do I put the x or the 3x? And the answer is it does not matter. And here's the reason why. You'll realize that it turns out to be the same. So if you divide by 3 over here, and it turns out the same. So here's one restriction. X cannot be equal to 0. And then over here, same thing. 20 or y, you could just take the variable. Now, what is important is if it had a variable and an exponent. So if that was like to the 3rd power, then that would be important to include. but in this case it's just a monomial. Y is not equal to 0. I don't have to do anything, it's already solved, so that's my restriction. Again, in this problem, we were able to perform the indicated operation, which is multiplication. Notice I don't have to do any flipping here, that would be division. List any restrictions for the variables. I just picked those denominators, my variables in the denominators. And then we're just simplifying when possible. That was question number 3 on the front side. Feel free to put any questions you guys have in the chat. The chat is live, so it will record. Or feel free to always ask me afterwards or during office hours. Question number 4. Perform the indicated operation, list any restrictions for the variables, and simplify the answer when possible. So I have x minus 2, x squared minus 8x plus 15 plus x over x squared minus 25. Okay, is adding them. And the reason why it's difficult, because in fractions, remember, you have to have the same denominators. Now, before I do the problem, I'm just going to see if it's factored. So I notice that x squared minus 8x plus 15 is not factored. So I'm going to do a little side problem. We've been working on factoring the whole year. You have a trinomial. Tri means 3. 1, 2, 3. It's in descending order to the second power, first power, and you can't see it. This is x to the 0. Half of 2 is 1. If that's the case, trinomial, and then half of the exponent is here. Then you can use this x method of factoring. This would be a times c, so that would be 15. Your b value is -8. Two numbers that multiply to be 15, I'm thinking are 5 and 3, but they have to add to be -8, so both of these are negative. Remember, when a is equal to 1, then you only need to use the x method. So I have x minus 2, and then our answer is going to be x minus 5, x minus 3. Okay, now I'm going to factor this one here in blue. Now, we did say that this one was a trinomial. 1, 2, 3. This one only 2 terms, so how do I make a binomial a trinomial? And what's tricky is that this is actually your c value. You're going to have to add a placeholder that would be 0x. So a times c is -25. My b value is 0. Need to think of two numbers that multiply to be -25 but add to be 0. These two numbers are going to be 5 and -5. 5 times -5 is -25, and 5 plus -5 is 0. So I'm going to have x plus 5, x minus 5. All right. Now, in order to add the denominators, the bottom part of the fraction has to be exactly the same. So let's take a look at this. They both have, I notice, an x minus 5 in common. This is good. So in class, we kind of did some color coordination. Let's see if I can find enough. They both have the double underlined x minus 5. This one has an x minus 3. This one is missing the x minus 3. So I'm going to have to multiply by x minus 3 on both sides here. This one has an orange, this one doesn't, so we have to be fair. Remember, you can multiply one side of the addition sign by 1, and it doesn't change in math. Let's take a look at this other one. This one has an x plus 5 here, but this side does not, so I'm going to have to multiply this one by x plus 5. And then you can see that now both sides of the plus sign both have an x minus 3, x minus 5, and x plus 5. All right, the next thing we got to do is we're going to multiply the numerators. So here is a binomial, 1, 2, times a binomial, 1, 2. So we have to multiply those. And over here we're going to distribute. And then now my denominators are exactly the same, so we have a common denominator. So I can just have x plus 5, x minus 5, x minus 3. All right, let's go ahead and multiply these over here. So I've been kind of using my side problem over here. Okay, so we've been practicing factoring. Now I'm going to just do the reverse that. This is just a box. And I'm putting these on the outside of the box. So I have x plus 5 and x minus 2. We're just going to multiply and then combine like terms. This is essentially FOIL. So I have x squared, negative 2x, 5x, and negative 10. And if I combine like terms in here, these two are like terms. So I'm going to get x squared plus 3x minus 10. All right, pay attention. Because this math operation is plus, I essentially don't need the parentheses, but I want to practice good math habits here. Attending to precision, standards of mathematical practice. And here, all I have to do is just distribute. A little more light. That didn't help. Let's see. Take away this one. I don't know if that's better or not. Okay, so when I do that, I get x squared and then minus 3x. So now again, the denominator stays the same, just repeat it. And now I can just combine like terms. You don't need the set of parentheses. Remember, I highlighted that just in case it was a subtraction, then you would have to distribute the negative sign. So 1x squared plus 1x squared gives you 2x squared. These are like terms here. 3x minus 3x actually equals 0x, so we don't have to write that, and then the minus 10. So this would be our answer. And it tells us, perform the indicated operation, which we did. We added these two together. I have to get a common denominator, so I had to factor. To review this, I had x plus 5. This one had it, this one didn't. So to add it, you're going to have to multiply by 1. That's why its top and bottom is the same. They had those in common. This one had x minus 3, this one didn't. Now it tells us to list any restrictions for the variables. What does that mean? Restrictions setting the denominator not equal to 0. Let's do the first one and you'll understand why. So here's my first restriction. And here's my second one. Let's set both of those not equal to 0. So we can zoom in. All right, so we already did the hard work of factoring these. x minus 5, x minus 3. And then from here, you can actually split them so that it says x minus 5 not equal to 0. And you don't need the parentheses there, so this, I'll do that for the second one. And then over here, we had said that this was x plus 5 from above and x minus 5. So I can set those not equal to 0. And so basically, I'm just solving for x, so I'm going to add 5. So x can't be 5. X can't be 3. X can't be negative 5. And we have a duplicate here. And you don't need to list the duplicates. So what are my restrictions? X cannot equal 5, 3, and negative 5. You don't need to list the restriction twice. It's like saying don't go faster than speed limit of 30 and don't go over the speed limit of 30. So this is question number 4. Apply the indicated operation and then the restrictions. Let's turn to the back side of your practice tests. Some more paper here. Question number 5. Given the function, complete the table. So it has this. We need to figure out, is there a vertical asymptote, a removable hole, and then a horizontal asymptote. So the first thing I'm going to ask myself, is it factored? Don't have to do anything there, don't have to do anything there, then it checks the box, it's already factored. The second thing is the vertical asymptote. Remember from the previous page, you're saying the denominator not equal to 0. So if you put your finger on the denominator is the bottom portion of the fraction. So let's go ahead and figure out the vertical asymptote. X squared is not equal to 0. If I take the square root of both sides, you're going to have x is not equal to, in this case, remember when you're taking the square root of an equation, it's both plus or minus. Now we would never say that x is not equal to a positive or negative 0, because 0 cannot be positive or negative, so the answer is x is not equal to 0. Our vertical asymptote is at x is not equal to 0. Let's use a highlighter so we can eventually graph that. Okay, removable hole. How do you find a removable hole? Is when you cancel something. So did we cancel anything? Or anything the same? The answer is no. X here, then you can cancel the x's, and what you canceled is your removable hole. But we didn't cancel anything, so there is no removable hole. The next thing is our horizontal asymptote. And what you need to do is compare the highest degree or exponent in the top and the bottom degree. So here, the degree is a small number. So what's invisible is x to the 0 power. Let me see if I can do it in a different color. So essentially you have 0 and 2. And then you're just going to look at your inequality. If your inequality 0 is smaller than 2, or 0 is less than 2, then if you look at your formula sheet, the ones we've been using in class, you will always have a vertical asymptote at y equals 0. when it's less than, it'll always be y equals 0. So that was question number 5. All right, question number 6. I'll get over really quick. Question number 6 says, using the characteristics in question number 5, so I know that's f of x equals 4 over x squared. Complete a table of values with at least 5 points. So let's make a table of values, x, y. One, two, three, four, 5. And I'm going to highlight the most important one. It's actually the middle. Or it depends on how many vertical asymptotes you have. I'm going to put this in pink. And if I kind of skip down to question number 7, it'll help me answer question number 6 visually. That's what I like. Question number 7 just tells you to graph what you have in 5 and 6. So we're going to make a graph of this. So if you draw yourself a coordinate plane, this is your x, this is your y number line. And it tells us that we have a vertical asymptote at x equals 0. Okay, this is the one I wanted to use and highlight to help you with your table of values. Notice this is x equals 0. So these are positive x values and these are negative x values. So 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4. And why this is so important is because the vertical asymptote actually tells you or gives you a hint of what numbers to pick for your x values. So I'm going to pick 0. That is my vertical asymptote. And I'm going to pick 2 numbers to the right. So like 1 and 2, negative 1, negative 2. So we're asked to complete this table of values. I'm going to show you guys by hand and then I'll show you guys by calculator how to get those values. Essentially what you're doing is 5 mini problems. You're taking your x values and you're putting them in here. Now if you need to do 5 mini problems you can. So I'm going to show you one of these. Let's do negative 2. F of negative 2. What does that function notation mean? It just means that this is your x value that we're picking. X is negative 2. And every x value we're going to put in negative 2. The numerator is 4. Negative 2 squared, that means negative 2 times negative 2, which is positive 4. And 4 divided by 4 is 1. You get negative 1, same thing. 4 divided by negative 1 squared. This gives you negative 1 times negative 1 is 1, so that is 4. If you put in 0 here, 0 squared is 0. 4 divided by 0 is undefined. Let's do that because that's such a big idea for what we're learning. It's like one of the biggest ideas of this whole test. 0 times 0 is 0. And this is a mistake for students. And I do allow you guys to have calculators. So let me pull up a calculator. And please feel free to put this simple problem into your calculator so you know. 4 divided by 0. Error. Can't divide by 0. Okay, why? Because it basically means undefined. What does undefined mean? It is a vertical asymptote. It's kind of like if I told you, take this stack of books and go to room 914. If you look in the math quad, there is no room 914. It's undefined. If I said go to room 911, 911 is defined. It is a physical room in a building in a place you can go to. Room 914 is undefined. Let's just finish this. So if you put in 1, 1 squared is 1, 4 divided by 1 is 4. And if you put in 2 here, 2 squared is 4, 4 divided by 4 is 1. So here's my table of values. Just pick your x values to the left, 2 to the right of the vertical asymptote, and you get those. Question number 7 tells you to graph all the characteristics from questions 5 and 6. So let's go ahead and do all these characteristics now. So I did the vertical asymptote. Now I'm going to do the horizontal asymptote. Okay, so big idea for rational functions when you're graphing them is it's split up into 4 regions, 1, 2, 3, 4. You can kind of see that in this specific problem. And what you want to figure out is if the graph is above or below it. It's not going to be in both, and one's going to be above or below. Now I can use my table of values to kind of help me. So let's arbitrarily put some numbers in. And I have -2, +1. -1, 4. 0 is undefined. Right 1. So I'm using these values over here. Right 1 on the x-axis, 4 on the y-axis. And then 2, 1. All right, so we know that this is a volcano. We learned about those characteristics of the rational functions. So I believe that answers all the questions in question number 7. Make sure you use a straight edge. All right, question number 8. Complete the table using the graph we did in 7. And it tells us to use interval notation. So 8a, we need to find the domain. 8b, we're going to find the range. 8c, we're going to find the end behavior. And 8d, we're going to find the Y-intercept. And I made this one an extra credit because I didn't teach it to you. All right, so let's look at this graph. Domain is the x values, and you're going to go from left to right. And with my graph, I'm going to go ahead on the x-axis. The negative numbers are on the left side. Positive numbers go towards the right. On the y number line, the negative numbers on the bottom, and that's where I'm putting negative infinity and then positive infinity. Okay, domain goes from left to right. Use your pen or pencil just like I'm doing. So I'm starting here on the far left side, and I have a graph. So notice I'm coming from negative infinity. So let me write that down, negative infinity. And you're always using parentheses with positive and negative infinity. The parentheses basically means don't include. You can't pick one particular negative number. They're all the negative numbers. And I have a graph, but I don't have a graph at 0. So we're going to put 0 parentheses. Don't include 0 because there's no graph at 0. And then I'm going to put U for union. We're joining the two sides together. I'm starting again at 0 on the x-axis, but it doesn't touch it, so that's why you do a parentheses. And you go all the way over to the right side. Remember, it doesn't matter if it's going up or down, it just means if you have a graph. And there's an arrow. It's going to go on towards positive infinity. And this is your answer for domain. Let's do the range. The range, you're going to go from the bottom to the top. And the range refers to the y's. So if I take my pen now, I have nothing here. And I'm starting here on the y number line. So if you can pretend, take the blue part out of your head and just have this part, the pink one, you're starting there at y equals 0. Remember, I don't include it because it's approaching but not touching. And there's a graph, yes, 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 yes. So there's always a graph all the way up to positive infinity. So this would be my answer for the range. This basically says all the numbers except for 0, what are the only numbers you can't pick in the problem, and this is where all your answers will be. So you'll always have a positive. End behavior. The end behavior refers to the arrows, and there's a sentence frame for that. As x approaches infinity, f of x goes to blank. X approaches negative infinity, f of x approaches blank. Okay, so in this one, we're just trying to figure out, does it go up or down? As the graph goes towards the right, x approaches positive infinity is right there. So as I go in this direction, where's my graph going? Is it going up? No. Is it going down? No. It's kind of landing here on my y values, because that's what f of x is, at 0. As x approaches the negative infinity, it's not going up, not going down, it's landing at 0, y values of 0. So that's your end behavior. Question number 8. Where is it crossing the graph? Where is it crossing the y-axis? That's what it means to be the y-intercept, and it does not. So the answer is, you can write DNE, or write it out, does not exist. That's a super fancy math word. Cheesy math word just means there is none. You're basically making your x value 0 for the y-intercept, and if you do that, you put in 0, 0 squared is 0, 4 divided by 0 is undefined. That's why we say it does not exist. All right, last question, number 9. On the back side of your practice tests, give yourself lots of space for this one. Expand each binomial and simplify. What is the third term? So I have number 9, x minus 4y to the 4th power. And it wants to know what the third term is. So I'll just do the whole problem, and then we can look back at the answer. Now, you could use the binomial theorem, which is a complicated form which I didn't teach you, or you could just use Pascal's triangle. So I don't have one in front of me. You have one on your formula sheet, so I'm going to go ahead and create one. So remember, just like it's raining outside, if you have a good roof, it just goes away, right? So the ones are just going to keep going on here. And then these two numbers, I don't know if you can see it. When you add these two numbers together, you will get 2. The 1 falls down here, the 1 falls down, and then you're just combining those two numbers. So 1 plus 2 is 3, 2 plus 1 is 3. Okay, so question, how far do you go? 1 plus 3 is 4, 6, remember you're adding here, 4, and then this is 1. This 4 here, you're going to come to this row here. So this power tells you what to pick. You're going to pick this row. And you're going to use each of these numbers, 1, 4, 6, 4, and 1. 1, 4, 6, 4, 1. And what I'm going to do is I'm going to assign A to be x. Okay, pay attention now. B is negative 4y. So watch as I do this. So I have a to the 4th power, and you're going to descend or go down a4, a3, a2, A1, A0. So A's, if you notice, it's on the left side of the binomial, left side of the parentheses, and then B value is to the right of the parentheses. So I'm going to start with B to the fourth on the right. B4, B3, B2, B1, B0. For now, we can just put in plus signs. All right, big idea for Pascal's triangle is with exponents, anything to the 0 power is equal to 1. Anything to the 0 power equals 1. You can kind of think of it as this way. Here's the reason why. You have x times x, there's an x. 0 x's, but you still have that 1 there. Okay, so this is a big idea for the Pascal's triangle, which means I don't need to write that. That's just 1. I don't need to write this one. That one I can just write b. And that one's just going to be 1. Don't have to write that. Don't have to write it. So let's write it again. But this time I'm going to have it's a long problem. Hard to zoom in there. Let's see if I can do my best. So I'm going to rewrite it without ones and zeros. So I have a to the fourth plus 4a3 times b plus 6a squared b squared plus 4ab to the third plus, don't have to write it, don't have to write it, and then b to the fourth power. Okay, now I'm going to go back and now substitute in my a values. So a is equal to x. And my b value, be careful with this one. Your b value is equal to a negative 4y. B value, negative 4y. So a is equal to x. And look what I did here. My substitution for a is equal to x, but it goes inside the parentheses. So the 4 should not be in the inside. That was your mistake from your quizzes. My a value is equal to x, and my b value is negative 4y. Notice I don't include the 4 there. 6, a is equal to x, exponent on the outside. B value is negative 4y. Now, the exponent goes on the outside of the parentheses. X, negative 4y to the third power, and then negative 4y to the fourth power. All right, we're almost done here. All we have to do now is just simplify. So I have x to the fourth. Okay, this one's going to be x to the third, y. We write them in alphabetical order. This one is just to the first power, so I can just multiply 4 times negative 4, which is negative 16. Okay, this one becomes x squared, and this one is now y squared. Now, this is not, and again, another mistake is 6 times negative 4. This is the order of operations, so we're going to use parentheses exponents. So this will become 16 times 6, which I believe is 96. Let me double check. So even I am using the calculator to double check my answer. Smart idea. Okay, for now, just put a plus sign, and I have 1x. This is going to be y to the third power. Negative 4 to the third power. Watch as I put that into my calculator. Negative. Texas Instrument, you have the negative sign. And then I'm going to use the caret. You might have an exponent button that is like x to the y. Negative 64, and I'm going to multiply that by 4. And I get negative 256. And then here, this one's going to be y to the 4th. Negative 4. Okay, this would be wrong. Don't put negative 4 to the 4th power. This reads it as negative 4 to the 4th power. But what I want, sorry, the last one reads it as 4 to the 4th power, and then take the opposite of that. I want negative 4 to the 4th power. That gives me 256. And let's go back with our answer now and just clean it up. X to the 4th, when you have two math operations, do a negative. This one again is going to be negative. So negative, positive, negative, positive. It actually alternates. And this is your answer. So go slow. You're going to have to do a lot of work there. Remember, you can use a formula sheet on your test. Let me double check by looking up the due date. So again, if you would like to take the test itself, let me just read to you what it says. You're going to have to take a picture of this practice test and your correction. So don't just show me that you did it correctly. It's actually better if you go back and you did it first time, and hopefully watching this video, you're writing the corrections on the right side. Remember, a complete sentence of what you did wrong, and then redoing the whole problem. And then you're also going to have to send me a video link of your, either in Google Drive or YouTube, you can make it private, that shows that you have completed all the homeworks above 137 to 146, because that's essentially a study guide. And you'll need to send me an email by, I believe, next Thursday, April 16th by 11:59 p.m. that tells me that you want to take it with all that work. And then I will send you the test on a Friday, April 18th, 2020 at 9:30 through email. And you'll have 1 hour to take the test. And you'll have to be, we'll probably do Google Meets. I'll send you a link once you send me an email. And that basically means I'm proctoring you or watching that you're taking the test without aid, either texting, talking to someone, looking online. And you send me back the test through email. But remember, you don't have to take the test. It's optional. But I hope this was helpful for you to study. Stay dry. Have a fun, safe, legal day.